Welcome back, everybody, to another deep dive. This time, we're going to be taking a look at decoding methods for foundation models.
Oh, cool.
Have you heard of these before? Things like large language models, LLMs, like
Yeah.
GPT-4,
Mm-hmm.
and large vision language models, LVLMs, like Google's Gemini.
Yeah, those are really cool.
They're really neat, right? They can do all sorts of incredible things, like understanding instructions, generating human quality text.
They can even reason.
I know, it's wild.
Really is mind-blowing how far these models have come.
Yeah.
Not just mimicking patterns anymore. They're
Right.
starting to show signs of, like, real comprehension.
Yeah, it's like you can show Gemini a picture of like a bustling market and ask it to describe what's happening, and it'll like paint you a picture with words.
Amazing.
But
Yeah.
here's the thing. Sometimes these models can be a little off, inaccurate, unsafe, even biased.
Right.
Not exactly what we're aiming for.
Yeah.
So
Yep.
that's where decoding comes in.
That's right.
And it's like having a guiding hand on the wheel,
Yeah.
steering the model's output in the right direction during its thinking process.
Absolutely.
Now, I know there's other cool stuff out there like prompt engineering and latent space manipulation.
Yeah, we can talk about that another time.
We'll get to those another time for sure.
Yeah.
But today, decoding is our main stage.
Okay.
We're going to explore three key paradigms: contrastive, guided, and parallel decoding.
Right.
Each one has its own unique way of shaping those AI outputs.
And what's so fascinating is the ingenuity within each paradigm.
Yeah.
Researchers are constantly coming up with new techniques,
Right.
constantly pushing the boundaries of what's possible.
Before we get into all of that, though,
Okay.
let's get the basics down.
Right.
So imagine the models choosing words one by one to build a sentence. Kind of like a super advanced word association game.
Okay.
That's the decoding process in a nutshell.
Right.
Early on,
Yeah.
methods like greedy search and beam search were the go-to.
Those are the classics.
Yeah, the OGs.
Yeah.
So greedy search picks the most likely word at each step,
Mm.
while beam search considers a few promising sequences.
It's a little bit more strategic in its choices.
Yeah, exactly.
Yeah.
But those sound pretty straightforward.
Yeah.
But they have their downsides.
They do.
So greedy search can get stuck in a rut, churning out repetitive or predictable outputs.
Yeah. And beam search, while better, can miss out on like those truly creative word combinations.
Yeah, exactly.
Yeah.
So then came the stochastic methods,
Right.
like top K and top sampling,
Right.
and they inject a bit of randomness into the mix,
Yeah.
making the outputs feel more human-like and diverse instead of always choosing the most obvious word.
Yeah.
These methods allow the model to take risks,
That's cool.
exploring less likely but potentially more interesting options.
Right. It's like adding a touch of spontaneity to the AI's writing.
Total.
Make it less predictable.
Yes.
And more engaging.
Like how we as humans sometimes surprise ourselves with our own word choices.
Exactly.
Then there's speculative decoding, which aims to decode multiple tokens simultaneously,
Oh, wow.
which can significantly speed up the process.
So it's much faster.
Much faster.
Got it.
Now think about you for a second.
Okay.
Have you ever interacted with a chatbot
Sure.
or used AI writing tools? Imagine how much smoother those interactions would be if the AI could generate responses instantly.
Yeah, that would be amazing.
That's what we're talking about here.
Wow.
And as we delve deeper into these decoding paradigms, think about what aspects pique your interest the most.
Okay.
Are you fascinated by the creativity of stochastic methods?
Yeah.
Or perhaps the sheer speed of parallel decoding?
Or maybe both.
We'll be exploring all of this and more, so stick with us.
Awesome. I'm excited.
Okay, so let's rip into that first decoding paradigm.
Okay.
Contrastive decoding.
Yeah.
It's like the model is having this internal debate, weighing the pros and cons of different output options.
Exactly. It's like a deliberation between good and bad choices as the model is generating text.
Okay.
There are two main types.
Okay.
Token-wise contrastive decoding, which focuses on individual words, and then layer-wise, which looks at different layers of the model.
Okay.
Almost like a mental filing cabinet.
Mental filing cabinet. I like that.
Yeah.
So let's start with token-wise contrastive decoding.
Right.
How does this internal debate actually play out?
Well, one way is to use an expert model to guide the output towards those desirable qualities,
Okay.
and an anti-expert to steer clear of those negative ones.
Okay, so like a good angel and a bad angel.
Exactly. Think of it as like a mentor, whispering good advice while also avoiding those pitfalls.
Gotcha.
So Dexpert is a good example of this approach.
Okay.
It's used for language detoxification and sentiment control.
Okay.
ensuring that the output is clean and matches that desired emotional tone.
So if I'm like using an AI to write a children's story, the expert model would be encouraging the use of playful and imaginative language.
Yeah.
And the anti-expert would be like, whoa, 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 hold on there, buddy.
Right, exactly.
Let's not get too scary.
Keep it PG.
Yeah.
Precisely.
Then there's context-aware decoding.
Yes,
This one makes sure that the model is paying attention to the relevant information,
that's right.
the context,
Yeah.
before generating the text.
It's like a detective piecing together clues
Oh, white lie.
to build a coherent story.
Makes sense if I'm asking an AI to write a sequel to a popular novel.
Right.
I want it to, like, stay true to the original characters and the plot and all that.
Exactly. You want to maintain that consistency.
Yeah.
And if you're dealing with like messy or incomplete input,
Mm-hmm.
adaptive contrastive decoding comes in handy.
Okay.
This makes the model more robust, able to handle things like typos,
Right.
grammatical errors,
Uh-huh.
even missing information
Yeah.
without getting derailed.
Oh, that's really helpful.
It's like an AI that can gracefully navigate real-world imperfections.
For sure.
Yeah.
Okay, now on to layer-wise contrastive decoding
Okay.
and those mental filing cabinets you mentioned.
Right.
What's the thinking behind that?
Well, research suggests that LLMs store different kinds of knowledge in different layers.
Okay.
Like those early layers might handle basic grammar and syntax, while later layers are dealing with more complex concepts
Right.
and reasoning.
So it's like the model's brain is organized into these specialized departments
Exactly.
with their own areas of expertise.
Yeah, like different teams working together.
I like that.
Yeah.
That's so cool.
It is.
So one method that uses this to its advantage is DOLA, decoding by contrasting layers.
Hefty name.
Right. And it compares outputs from different layers, giving more weight to the ones that align with factual information.
Right, so it's trying to ground the model's output
Okay.
in reality.
So it's reducing the chance of hallucinations.
Exactly, making things up, which can be a problem sometimes.
So if I'm using an AI to like answer factual questions,
Mm-hmm.
DOLA would make sure that it's pulling information from those knowledge layers
Right.
rather than just like making things up.
Exactly. It's like double-checking its work
Okay.
to ensure accuracy.
That seems crucial, especially if you're relying on that AI for like important information.
Absolutely. You want to be able to trust the information.
Yeah, for sure.
And then there's valid,
Okay.
which plays a similar role but for vision language models.
Okay.
So it ensures that the generated text actually matches the image being processed.
So it's preventing those mismatches.
Exactly, those hallucinations we were talking about earlier.
Yeah.
So if you show an AI a picture of a cat playing with a ball of yarn,
Mm-hmm.
valid is going to make sure it doesn't describe a dog chasing a frisbee.
Right.
You want the description to align with what's actually in the image.
So it's keeping things accurate and grounded.
Precisely.
Now, as we've been like exploring these contrastive decoding methods, what are your thoughts so far? Do you find this concept of this internal debate within the AI fascinating or maybe a little unsettling?
I think it's fascinating to see how these models are becoming more nuanced in their decision-making processes.
Mm-hmm.
Almost like they're developing a sense of critical thinking.
Totally.
Yeah, it's really interesting.
Okay, so ready to move on to guided decoding.
Yeah, let's do it.
Okay, this paradigm is all about providing the model with a map
Right.
to navigate the vast sea of output possibilities.
It's like giving it a set of guidelines or a roadmap to follow.
Exactly. It's about nudging the model in the right direction without like being overly restrictive.
Right. You want to give it some freedom, but also some guidance?
Yeah, exactly.
So we can think of it as falling into two main categories.
Okay.
Classifier guided, which uses external tools to steer the output,
Mm-hmm.
and then heuristic guided, which relies on like rules of thumb or search strategies.
Okay, so let's start with classifier guided decoding.
All right.
What kind of classifiers are we talking about here?
Well, these classifiers can be anything from sentiment analysis tools to reward models.
Okay.
Essentially, they provide feedback to the model
Mm-hmm.
during that decoding process,
Okay.
helping it steer towards outputs with those specific desired attributes.
So if I want an AI to write like really positive, upbeat marketing copy, I could use a sentiment classifier to make sure the output stays optimistic.
Exactly. You could train it to avoid any negative language.
Right, and just be like super pippy.
Keep it positive and encouraging.
Yeah.
So one early example of this is plug-and-play language model, or PPLM.
Okay.
It allows you to easily integrate external tools like those sentiment classifiers
God.
to guide the output.
And then there's reward augmented decoding.
Yeah, or RAD for short.
RAD, this one sounds a bit like training a pet,
Right.
giving points for good outputs.
You got it. It's about reinforcing those desired behaviors by rewarding the model when it generates text that aligns with our goals.
Cool.
Yeah,
And for those who are like concerned about the potential risks of AI, there's safety coding,
that's right.
which utilizes an expert model
Yes,
to make sure the outputs are not only helpful, but also harmless.
exactly. It acts as a safeguard, preventing the model from generating anything offensive,
Okay.
inappropriate,
hmm
or potentially harmful.
So, like, that's a really important consideration as we're developing these increasingly powerful systems.
Absolutely. We want to make sure they're used responsibly.
Okay, now shifting gears a bit, let's explore heuristic guided decoding.
Okay.
This one's all about using rules of thumb or search strategies.
Right. It's about leveraging those heuristics to guide the output.
Okay.
So one interesting example is FUDGE.
FUDGE.
Yeah, which stands for Future Discriminators for Generation.
Catchy.
I know, right?
So, what does FUDGE?
It tries to predict how the output will unfold as it's being generated,
Oh, wow.
allowing for like real-time course correction.
So, it's like the AI is constantly checking its work as it goes.
Exactly, making adjustments along the way to stay on track.
Okay, cool. Then there's neurologic decoding,
Yes.
which uses logic rules to constrain the output.
It's like having a built-in logic checker
Okay.
to ensure that the AI's reasoning is sound.
So if I'm asking an AI to like solve a logic puzzle, neurologic decoding would make sure that it's following those rules of logic.
Precisely.
Okay, and avoiding any fallacies or contradictions.
It's all about maintaining logical consistency.
Yeah. That seems essential for tasks that require like rigorous reasoning.
Absolutely. You want to make sure the AI is thinking straight.
Yeah, for sure.
And finally, for all the coding enthusiasts out there,
Oh yeah.
we have Planning Guided Transformer Decoding, or PGTD.
PGTD. Okay, tell me more about this one.
This method is specifically designed for code generation.
All right.
The model actually plans ahead to write better code,
Whoa.
breaking down the task into steps and using test cases to see if it works.
So it's like thinking like a programmer,
Exactly.
anticipating potential problems,
It's trying to be proactive.
testing its solutions as it goes.
Yeah, it's like a self-debugging AI.
That's incredible.
Yeah, it's pretty amazing how sophisticated these models are becoming.
Totally. So as we've been exploring these guided decoding methods, what strikes you as the most innovative or potentially impactful?
I think the ingenuity of these methods is really impressive. What I find most exciting is the potential for these techniques to make AI systems more reliable, more creative,
Yeah.
and aligned with our goals as humans.
Okay. I'm excited to keep learning more about these.
Well, good, because we're not done yet. We still have one more paradigm to explore:
Oh, right.
parallel decoding.
Okay, let's dive into that one. Okay, so parallel decoding, this is the last paradigm.
This is the one where speed is key.
This is the speed one.
Yeah, exactly.
Okay.
Especially in a world where we're working with these increasingly massive models, efficiency is everything.
All right.
Imagine you're waiting for an AI to write you a song
Mm.
or like generate a really complex image. You don't want to be sitting there staring at a loading bar forever.
Nope. Nobody likes that.
No.
So how does parallel decoding tackle this? Does it like involve multiple AIs all working together or something?
It's more about the AI working smarter, not harder.
Okay.
So instead of generating like one word at a time, parallel decoding tries to generate multiple words simultaneously
Okay.
and then checks to see if they all make sense together.
But that sounds like it could get kind of messy.
It could, but that's where the clever algorithms and verification steps come in,
Okay.
to ensure that the output is still coherent and high quality.
So it's not just like a jumbled mess of words.
Right, exactly.
Okay.
And within parallel decoding, there are two main approaches.
Okay.
So you have the greedy methods, which prioritize speed above all else. And then you have the sampling methods, which inject a bit of randomness to allow for more diverse and creative outputs.
Okay, so let's start with the greedy methods,
All right.
the speed demons.
Yeah, the ones that are all about efficiency.
So what makes them so fast?
Well, one common technique is blockwise decoding, which breaks down the task into chunks, making it faster to process.
So it's like writing a novel a paragraph at a time.
Exactly, instead of word by word.
Gotcha.
Streamlining the process.
What other tricks do they have?
Well, there's also self-speculative decoding,
Okay.
and that uses the same model for both drafting and verifying the output.
Oh,
So it's like the AI is proofreading its own work as it goes.
Gotcha. So it doesn't need like another helper model.
Exactly. Very efficient.
That's awesome.
Yeah.
Okay, what about look-ahead decoding?
Look-ahead decoding lets the model peek ahead, considering future possibilities before actually making a decision.
So it's strategizing several moves in advance.
Exactly like a chess player.
Cool. Okay, now on to those sampling methods.
All right, so these are the ones that add a little bit more creativity.
Yes.
So speculative sampling adds an element of randomness to the parallel decoding process,
Okay.
allowing for a greater diversity of outputs.
So it's not just sticking to a rigid formula.
Right, it's exploring different creative avenues.
Exactly.
And then there's distill spec.
Distill spec.
This one uses a smaller distilled version of the model to generate those initial drafts quickly.
Okay.
And then those drafts are checked and refined by the larger, more powerful model.
So it's like having a talented assistant do the initial brainstorming.
Exactly.
And then you bring in the expert to really polish it up.
That's a great analogy.
So as we're wrapping up this whole deep dive into decoding, what stands out to you as like the most promising or groundbreaking thing about all of this?
You know, it's incredible to see how rapidly these decoding methods are evolving.
Yeah.
What excites me the most is the potential for these techniques to not only make AI faster and more efficient, but also more creative, more reliable, and really aligned with our human goals.
It's like we're on the verge of something truly transformative.
Absolutely. And it begs the question, if we can steer AI outputs in these really powerful ways, what does that mean for the future of like human AI collaboration?
Will we be partners or something else entirely?
It's a really fascinating question.
Yeah.
And understanding the nuances of decoding,
Yeah.
I think, gives us a really valuable lens through which to view all of these developments.
Well, we've covered so much ground today.
We have.
From the basics of decoding all the way to these super intricate methods.
Lots of new terminology.
Yeah, right.
But hopefully it was all clear.
But I hope this deep dive has given you a new appreciation for like the power and potential of decoding.
Yeah, absolutely.
And if you're eager to like explore further, be sure to check out the show notes.
Yes.
There's a link to the research paper there.
It's a treasure trove of information for those who want to dive even deeper.
So until next time, keep exploring, keep questioning.
And keep pushing the boundaries of knowledge.
And keep decoding those fascinating advancements in AI.
We'll see you on the next deep dive.
Bye, everyone.